Hello viewers, this is a small presentation demo on automatic washing machine which is developed by me as a part of embedded system internship in EMERTXE. My name is Krishna Mahapatra. I am from PMEC Berhampur. Then introduction. The washing machine has a significantly impact modern society by reducing the physical efforts required for laundry tasks. It serves as a crucial application for effortlessly washing various types of clothing. Fully automatic machines offering a functionalities like washing, spinning, and heating in cycle are preferred by users over semi-automatic ones. Advancement in technology, particularly in embedded systems, have led to a diverse range of washing machine models with additional features. Features such as programmable spin timers controlled by microcontrollers like PIC 16F877M enhance the efficiency and functionality of washing machines. Overall, washing machines have become an indispensable part of daily life, simplifying the tasks of laundry for countless individuals. Then, need of C programming in embedded system. Why we need the C programming? In the embedded system domain, where power efficiency is crucial, C stands out for its optimization capabilities, particularly in memory uses through pointers. Its widespread use across various software development sectors, including system software, firmware, middleware, and file system, underscores its versatility and indispensability. With its pre-formatted structure, C remains a top choice for ensuring efficiency and reliability across diverse domains. In C programming, we have studied that is data representation, that is bit, byte, and word, integrated number, that is positive number and negative, and data types are integral, character, int, floating point, float, that is double, and conditional structures are a single iteration, that is if else if, and switch case. Multiple iterations are while, do while, and for cert, and unconditional are continue and break. And in embeddeds, we have learned from embedded CR operators, that is operates on its operands and returns value. Array, a collection of data of same data type, that is address or sequential. Then pointer, that is parameter passing mechanism in function by passing the reference. Then function, pass by value and pass by reference, return more than one value from a function. Passing array, returning array, and recursive. Then strings are continuous sequence of characters easily stored ASCII 2 and its extensions. Then storage class, it's a auto register, static local, static global, and extern. In embedded system, any combination of hardware and software which is intended to do a specific task can be called as embedded system. An embedded system is a microcontroller or microprocessor based system which is designed to perform specific tasks. Its purpose is to control the device and allow the users to interact with it. It consists of a microcontroller with onboard memory, a power supply, and communication ports for transmitting data to other devices. In what is the challenges in embedded system? In embedded system, efficiency and input and output, and embedding and operating system, code optimization, and testing and debugging. These are the challenges. Then types of embedded system. In There are two types, that is based on performance functional requirements and based on performance on the microcontroller. On the performance and functional requirement, there are four types, that is real-time, standalone, networked, and mobile. And based on the microcontroller, that is small scale, medium scale, and sophisticated. This is the general block diagram of a microcontroller embedded system, whereas a microcontroller uh, sensors are displayed and output interfaces are shown. Then why we select a not microprocessor? A microcontroller, a single chip integrated circuit, functions as a compact computer within electronic system. Its MOS based, that is metal oxide semiconductor based design, incorporates a microprocessor memory and associated circuits, simplifying system control. Programmable for specific tasks, its efficiency manages inputs and directs signals with the device, streamlining functionality and reducing design complexity in embedded systems. Then microprocessor. Uh, uh, the microprocessor contains the arithmetic logic and control circuit required to perform the functions of a computer CPU. We need to connect the peripheral externally, so it makes circuit bulky. Due to external components, the total power consumption is high. Therefore, it is not ideal for device running on the stored power like batteries. Then component. What is the our project requirement? Our project is based on PIC 116F 877A microcontroller, and these are its following requirements, that is hardware parts and software parts. In hardware parts we have need a CLCD, LEDs, keypads, interrupts, timers, buzzers and fan, and microcontroller. And software parts we have need for MPLAB XID for code writing, XC8 is a compiler, and PiximLab is simulator. Then microcontroller. The PIC16F877A features 256 bits of EEPROM, data memory, self-programming, and LCD, two comparators, 8 channels of 10-bit analog to digital converter to capture compare PWM function. The synchronous serial port can be configured as either 3-wire serial peripheral interface or the 2-wire integrated. PIC 16F877A is a 40-pin microcontroller designed using RISC architecture manufactured by Microchip and is used to embedded project. It has 5 ports on its starting from port A to port E. It has 3 timers in it, 2 of which are 8-bit timers, which while one is of 16-bit. Here we can see the pin diagram of PIC 16F877A. Then keypads. Keypads is a matrix keypad. We need to configure rows as output and columns as input. The switch activates when passes and then turns off when released. Keypads are used to give input by the users in binary format. They consist of push button. There is a metal plate and terminal. Suppress pulse detection while pressing and releasing the tactile switch, which is called bouncing effect. They can trigger in two different ways, that is level triggered and edge triggered. In level triggered, activate when voltage is on, voltage is one high level. In edge triggered, it is activated when voltage is suddenly changes. Then come to two different configurations, that is source circuit and string circuit. When one is pressed, that is on, and 0 is pressed, that is off. When in shrinking circuit, 1 is defines to off and 0 is defines on. Then interfaces LEDs. Simplest device used in most of the embedded application has feedback, works just like diodes. LEDs are connected to port B and port D. Port is a peripheral and we need to know how to access and address each peripheral. From the section of port B, it is clear that there is one more register associated with name trees. Trees register is very important for IO configuration. Then this is the demo of LED based program. Short basic LED program, that is toggling LEDs connected to port B. Build hex file in MPLAB XID software. Then in PiximLab software, load the hex file in. Then board PIC Genius board. Then we have choose the controller, that is our PIC 16F877A. Then data processing in CLCD. CLCD is a dot matrix liquid crystal display, can interface with 4-bit or 8-bit microcontrollers. Its pin includes our VSS, that is ground, VDD, that is voltage, contrast control, that is VO, register select RS, then read enable, that is its value should be this value should be either 1, and then read and write, uh, read and write, and data lines, that is D0 to D7. Addressing involves toggling RS, that is register select, for selecting addresses and initialize. In a 16 is to 16 cross 4 LCD, addressing is based on rows and column. Data processed by two methods, that is delay method and poll D7 method. In poll D7 method, we want to continuously monitor D7. In data lines, we are providing data, that is read and write is 1, that is read, and read and write is 0, that is write. In read write pin is permanently grounded, that means only write and data. In CLCD, D0 D7 are connected to port D, and RS and enable pin are connected to port E, that is 8-bit, that is D0 to D7, and 4-bit is, that is D4 to D7. The enable pin signals LCD about the start of the data transmission from microcontroller. Then we have next is timers. Timers is nothing but a simple binary counter that can be configured to count clock pulse, that is internal or external. Once it reaches the maximum value, it will roll back to 0, setting up an overflow flag and generates the interrupt if enabled. PIC 16F877A has a 3 independent timers which can be used as a timer counters or for PWM generation. There are timer 0 that is 8-bit timer, timer 1 16-bit timer, timer 2 8-bit timer. Prescaler part of the microcontroller that divides oscillator clock before it will reaches logic that increases timer status. The frequency of the crystal oscillator, that is 20 megahertz, as the timer increments, and when it reaches its maximum value of 255 for 8-bit timer or 65536 for 16-bit timers, it will trigger an interrupt and initialize itself to 0 back again. This interrupt is called as the timer's interrupt. Then we have interrupt. An interrupt is a communication process which causes the processor to stop it uh, current task and handle interrupting source. Source is that may be external and internal. Interrupt depends on two factors, that is interrupt vector table, interrupt service routine. In interrupt vector table, that is data structure that associated a list of interrupt handles with a list of interrupt requests in a table of interrupt vectors. In interrupt service routine, a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, executes the handling, and then returns a logical interrupt value. Peak has only interrupt service routine. Then buzzer and fan. To turn on the buzzer, we have choose RC1, that is we have give the value input as 1. To turn on the buzzer, we give RC1, that is value 0. Data direction register is try C1, that is 0. We give out give as output, and text, if we have give the value as 1, it gives uh, input. In fan, to turn on the fan, we have choose the RC2 uh, register. Then if we give the DDR tricks to value to 0, it shows output, and if we give the value input 1, it shows input. And then softwares, we have used three softwares, that is MPLAB XID and its compiler, that is X8 compiler, and PiximLab stimulator emulator. MPLAB XID is a free integrated toolset for the development of embedded applications on microchips, PIC and DSPIC microcontrollers. It is called an integrated development environment or IDE because it provides a single integrated environment to develop code for embedded microcontrollers. PiximLab. In PiximLab is a real-time emulate for development boards with integrated MPLABs, AVR, GDB debugger. For code editing and debugging, the same tool used for real boards should be used with PixelLab such as MPLabX or Arduino IDE. And then comes to X8 compiler. Is a C compiler from Microchip for 8-bit PICs. Both programs run on Windows, Mac OS, and Linux. Then procedure. How should we start our project building? As soon as as we power on the device, so we want stimulator to show a message like powering on washing machine. After powering on, the simulator should show all the washing modes. Simulator also contain matrix keypad, and with the help of its key, we will able to choose respective modes. In this particular design, we include a pause button that will pause the time count and will turn off the device until it released. After completing the event countdown of X second time of message will be displayed on CLCD. Then let's see a demo of our project. So here is our project model, demo model, in which we have to load our text file, that is washing machine. Uh, so in our CLCD it shows press key 5 to power on washing machine. We have, as we press, it shows our washing machine programs. We have used 12 different types of washing programs. If we press the key 4 to scroll down, different types of washing programs. For example, I have to choose uh, daily. For choosing the washing program, we have to long press the key F4. Then it shows a water level. We have four different kinds, five different kinds of water levels. That is auto, low, medium, high, and max. For example, I have to choose high as my water level. Then I have to press the key for selecting the water level. As long as I press the key for select, it shows press switch. That is switch 5 to start our program, but that is washing, and press switch 6 for return to the water programs. Sorry, washing programs. Then we have choose uh, key 5, that is RB4. Then it's started. Then our fan is turned on, and it's countdown it started. If I press the key 5, uh, if I press the key 6, then it pause, where our countdown also pause. And if I key 5, then it resumes where it paused. Then uh, if we open the gate in function, then it shows uh, warning, that is door is open, then please close the close the door. Then it's also started. In function we have three washing types, that is wash, rinse, and spin. In wash, that is 46%, rinse is 12%, and rest, then spin is rest of the total time. So now let's move to our code part. So here is our code, where we have our main source file, main.c source file, where all that is CLCD, digital keypad, timers, all files are we have added. In the coding part, we have given the array input to our 12 different types of washing programs, then five types of water level. Then moving down to here, we print our CLCD programs. Then here we set our water level. That is, we have, if we press the key, different type keys, then it's shows press switch 5 to start, and switch 6 to stop. Then in in switch case operation mode, uh, we have uh, we have uh, we have displayed different kinds of washing programs, and we have used continue and break statements. Then coming to our power on screen, uh, how much our in CLCD, if we turn on, then it shows powering on the washing machines that we have used. Then washing programs in display, what are the different washing programs we have, that is source our CLCD. Then here we use to select, uh, to scroll down to select the different types of water levels to choose to operate in washing machine. Then we have set the times for different kinds of waters. For daily we have used 33 seconds. For uh, for uh, for heavy, sorry, uh, mm. For whites we have selected 1 minute and 16 seconds. For stainless I have selected 1 minute 36 seconds, and etc. These are the time value. Then we have used run program, that is we have in our CLCD it shows how much uh, time and seconds it countdown from descending order, that is descending in manner. Then we have used three types of in our washing three types of washings in our washing machine, that is three types of programs in washing machines, that is wash, rinse, then spin. Wash is of 42%, rinse is 12%, and spin is rest of the total time. Then to if our program washing is completed, then it shows wash is completed, then remove cloths in our CLCD, then with a buzzer. Then door, if our if washing in washing time, if we accidentally open the door, then it starts with a buzzer and shows warning to door is open, please close. Then here we and our code. Then moving to conclusion. uh, Conclusion. The washing machine stimulation using Fixing Lab served as an effective tool for learning and applying concepts in embedded systems. It offered a hands-on experience that complemented theoretical knowledge and provided a foundation for the further exploration in the field of automatic and control systems. Thank you.